Hello, legacy students, Marsh here. So today we're going to look at rational exponents and radicals. Basically, we're going to see how do rational exponents, aka fraction exponents, relate to radicals, which is like square roots and cube roots. What you're going to have on you, notes, pen or pencil, and then you're also going to definitely want a calculator today to be able to look at. So a little bit of new notation, guys. A radical, like I said, is a perfect, or looks like a square root. A radical is the actual little sign that we use to show a square root. The number in the inside, that is known as a radicand. And then a number, if there is one, is the index. Now, usually you do not see the index on a square root because the 2 is an understood number. But, however, indexes, you can have a 3 out there, that would be a cube root. 4 would be a fourth root, and so on and so on. Then we also have what's known as a rational exponent. Basically, it's a fraction that's an exponent. Let's look, though, how are roots related to fractional powers? So 25 to the 1/2 power is 5. 36 to the 1/2 power is 6. 49 to the 1/2 power is 7. And 64 to the 1/2 power is 8. How are these related? How is 25 related to 5? They're square root, right? The square root of 25 is 5. I wonder if that's the same thing with the 1/3 power. So 8 to the 1/3 power is 2, and 64 to the 1/3 power is 4. 2 to the 3rd is 8. So if 8 to the 1/3, that's 2. Well, these kind of have a relationship. If you have x to the 1/2, what that basically means is that you're going to take the square root of that number. So in a radical form, it's going to look something like this. A square root of x. Now, like I said earlier, there's a 2 technically here. It's not needed to be written. However, if you wish to write that 2, I'm not going to be opposed to that. But the 2 is understood. If there's not a number there, it's an understood square root. X to the 1/3, that's the same as a cube root. So that would look something like this. Same thing, but notice there's going to be a little 3 hanging out there. That is you telling it that it is a cube root. Same thing if I have x to the 4th, that's a 4th root. So that would look something like this with a little 4 down there. But now, what about something that has a fractional exponent, something like 8 to the 2/3 power? How on earth are we going to figure out what that is? Well, there's a pattern to it. To change forms between radicals and rational exponents, what you're going to want to do is you're going to first break this m over the n. So remember, if I multiply, basically it's a power to a power, right? It's the power rule that we had for exponents. So what I can do is I can write as a to the 1/n power to the m power. Then a to the 1/n is the same thing as the whatever n root of a still to that m power. It's actually pretty simple. Let's go over a couple of examples. By the end of this, you're going to be an expert at this. So, I have 7 to the 1/2 power, and I want to write that as a radical notation. Well, what you're going to do is the number outside here is going to go on the outside of your radical. This is going to be your radicand, the big number. And then this number outside here, the top one, he's going to go on the outside of parentheses. Now, since this is to the 1st, I technically do not have to write that. I could have wrote square root of 7. That's all I would have needed to written. What about this one? Well, this guy, if we change him, we're going to put our radical here. The big number is going to go on the inside. The outside number, I can rewrite this as 4 to the 1/3 power to the 4th, right? Because 4 times 1/3 is 4/3. Well, cube root of 4, that is the same thing as, or 4 to the 1/3 power, excuse me, is the same as the cube root of 4. And I can take that to the 4th power. I changed it to radical notation. Let's try this one again. So this is 2 to the 1/3, right? to the 5th power. So 2 to the 1/3 is the same as the cube root of 2. And then still to the 5th power, because this is equal to that, right? So I can basically change these two interchangeably. Now let's try not to write with that middle step. So I know I'm going to have a radical of 7, right? Because that's my radicand. This is going to be your index, 3, all to the 4th power. Same thing here. This is 6 to the 1/2 to the 3rd. 6 to the 1/2 is the same as the square root of 6. Notice I'm not going to put the 2 there because that's an understood 2. And then to the 3rd power. And then the 6th root of 2 is the same as 2 to the 1/6. Not too bad, right? Same pattern over and over. So bottom number goes outside the radical. The radicand's the big number, and the top, the numerator of the fraction, goes outside parentheses. Now, let's try to go backwards now. Now, notice I do not have an index, so we can assume my little index is a 2. So, if I rewrite this inside here, that is 10 to the 1/2, right? So then, take those, multiply. 1/2 times 3 is 3/2. So this is 10 to the 3/2 power. No number out here, but I can change that. That is 2 to the 1/6 power. Since there was no number here, technically that's a 1. 4th root of 2 to the 5th power. Let's change the inside. So that's 2 to the 1/4 over 5, or 2 to the 5/4. No number outside, so that's going to be 2 to the 1/3 power. Little 1 here, right? Because there's no number. So it's going to be 10 to the 1/6. So the index is on the bottom of the fraction. That's the denominator of your fraction. And then this one, I'm not even going to convert the inside first. I'm just going to go for it. So 10, index is the denominator. That is the numerator. So that would be 10 to the 7/3. Now, ultimately, you're going to want to be able to evaluate this stuff. So, you need to know how to plug it into your calculator. If you have a calculator that looks something like this, a 30x2s, or any Texas Instrument, to type this in, you would do 3, and then you would find a button. It's right here on your calculator. It has an x square root, or a little x, and then it has the square root as well. You're going to push that, and then you type -8. So what this does is it makes that 3 become the x. You should get an answer of -2. If you have a, let's say you're using your phone's calculator, you do need to get a scientific version. Usually that's by turning it to the side so then you can get the full keyboard. On they believe this would be a iPhone. It's one that looks like this, x square root y. So you would push 4, and then square root x, y, and then 625. You should get the 4th root of 625, which is 5. If you have any trouble finding these in your calculator, please ask. I can definitely help you. Now, for me, I hate using the radical. I think it's a little clunky. I like to transform them into exponents, rational exponents. So, this is going to be just as simple as it is on when you would normally took an exponent. So, like 4 to the 3rd. So, you would have gone 256 caret, and then put in parentheses 1 divided by 4. Or you can use this with your fraction key on your calculator. You should get a 4 for that one. And then 32 to the 1/5 is 2. And if you have any trouble finding those, definitely let me know. So you can convert these back and forth. This would be 32 and the 5th root of 32. I think this is easier to type in personally, 32 to the 1/5. However, some people like to use the radical. Now, what about evaluating without the calculator? It's kind of a little quicker, not as clunky. You're going to want that perfect roots chart that we made together in class that you filled out. Now, evaluating without a calculator. You're going to have to kind of pay attention to this because it is very confusing. So 25 to the 3/2. What you're first going to want to do is you're going to want to convert that into the radical notation. So then I notice I have the square root of 25. So what I'm first going to do is I'm going to start at the squares column and run my finger down until I hit 25. Right there. Then I'm going to move all the way to the left, and I'm going to see it's a 5, right? So I can rewrite the square root of 25 as 5, and then I still have that cubed. Let's find out what 5 cubed is. So 5 cubed, run both my fingers till I hit intersect, that is 125. So my answer would be 125. So 25 to the 3/2 power is 125. Let's try 125 to the negative 2/3 power. So I'm first going to rewrite this as the cube root of 125 to the negative 2 power. Let's convert this. So cube root of 125. So I'm going to start in the cube column right here. Go down until I hit 125. Whoop, there it is. Let's go to the left. Let's find out what the number is. 5. So this right here, cube root of 125, is 5. 5 to the negative 2. Well, before you do that, let's use our exponent rule. Drop the negative down to the bottom of my fraction. So now I have 1 to the 5 over 5 to the second power. 5 to the second, 5 squared, 25. So I have 1 over 25. Let's try another one here. So 5th root of 32 to the negative 2nd. So if you follow the 5th power section of your perfect roots table, go down till you hit 32. Go over, it looks like it's 2, right? So this is 2 to the negative 2 power. Flip that, so it would be 2 to the 2nd, right? So 1 over 2 squared, which is 4. Let's try this one. 3 to the cube root of negative 27. So I'm going to look under the cube root section here. 27, go over the left. We get 3, but notice it's a negative 27. You can take a cube root of a negative. You can't take a even root, so a square root or a 4th root or a 6th root, you can't take it out of a negative. If you have a cube root or a 5th root, you can. So this is actually negative 3 squared. Because think about it. If I multiply negative 3 by itself 3 times, I get a negative 27, right? So then negative 3 squared is 9. So it's using that perfect roots table to get yourself very accustomed to using it. That way it's not as slow as typing into your calculator. If you, and some of them you will not be able to use the calculator, or you will have to use the calculator because they're not perfect roots and you're going to want some decimals on those ones. That's the end of this video. See you later, Sabers.